Physics MTP3 question number 5. In this question, a particle is moving with one component of constant velocity parallel to the axis of y and another component of velocity parallel to the axis of x proportional to y. And we have been asked what kind or what type of path it will follow. Now, as we know that when a body is moving parallel to the axis of y and it has a velocity which is also parallel to x-axis, its intersection point will be a parabola, and in this question it will derive or it will describe a parabolic path. So the correct answer here will be option B.
MCQ question number 8. In this question, an adiabatic vessel contains 2 kg of water at 25 degrees centigrade or 298 Kelvin, and the temperature of water is increased to 30 degrees centigrade or 303 Kelvin. If the specific heat of water is 4.187 kilojoule per kg per Kelvin or 1 kilocalorie per kg per Kelvin, then we have to find out the change in entropy of the universe. So we know that in the adiabatic container, heat exchange from the surrounding is 0 or change in heat delta Q is equals to 0. So that change in entropy of the surrounding will be 0. That implies delta S of surrounding equals to 0. Similarly, the change in entropy of the system delta S of system equals to integral from T1 to T2 dq upon T, where dq is equals to mc delta T. That implies integral from 298 Kelvin to 303 Kelvin mc dt upon T. That is equals to mc ln 303 upon 298. By putting the values, we will get change in entropy of the system, that is equals to 0.13934 kilojoule per Kelvin. MCQ question number 9. In this question, we have a gas of mass 8 kg which follows the given equation P into V raised to power 1 upon 1.2 equals to constant. The gas expanding within a flexible container. So in this process, the initial pressure equals to 1000 kilopascal, initial volume equals to 1 meter cube, final pressure is 5 kilopascal, and change in internal energy delta of U equals to minus 40 kilojoule per kg. So for 8 kg, change in internal energy delta of U equals to minus 40 into 8, that is equals to minus 20 kilojoule. In this question, we have to find out the change in heat in this process. The given equation in the question is similar to PV gamma equals to constant. So the given process is adiabatic. So for the adiabatic process, the equation of state is P1 minus gamma T gamma equals to constant, and similarly TV gamma minus 1 equals to constant. So P1 1 minus gamma T1 gamma equals to P2 1 minus gamma T2 gamma. So T2 upon T1 raised to power gamma equals to P1 upon P2 raised to power 1 minus gamma. That implies T2 upon T1 equals to P2 upon P1 gamma minus 1 upon gamma. Again, T1 V1 gamma minus 1 equals to T2 V2 gamma minus 1. So T2 upon T1 equals to V1 upon V2 gamma minus 1. That implies P2 upon P1 gamma minus 1 upon gamma equals to V1 upon V2 gamma minus 1. That implies P2 upon P1 raised to power 1 by gamma equals to V1 upon V2. That implies V2 equals to V1 P1 upon P2 raised to power 1 by gamma. According to solution, gamma equals to n. So V2 equals to 1 into 1000 upon 5 raised to power 1 upon 1.2. By solving to this one, we will get V2 equals to 82.7 meter cube. So work done under the adiabatic process, that is equals to 1 upon gamma minus 1 in bracket P1 V1 minus P2 V2, that is equals to 1000 into 1 minus 5 into 82.7 upon 1.2 minus 1. Then the work done in this process, W equals to 2932.5 kilojoule, and change in internal energy, that is equals to delta of U minus 320 kilojoule. So change in heat. So according to first law of thermodynamics, we know that delta of Q equals to delta of U plus delta of W, that is equals to minus 320 plus 2932.5. Delta of Q equals to 2612.5 kilojoule. Answer A.
Physics MTP3 question number 16. In this question, a proton and an alpha particle accelerated through the same potential difference enters a region of uniform magnetic field normally. We have been given that if the radius of the proton orbit is 10 centimeter that of the alpha orbit, then the radius of the proton orbit will be equal to which of the following options. Now, as we know that the force or the energy can be defined as potential energy for the particle will be Q times V, which will be equal to the kinetic energy possessed by the particle, which is half mv square. We also know that the magnetic force QVB will be equal to the circular centripetal force, which is mv squared by r. Using these two relations, we can define r equals to 1 by b under root of 2mv by q. If we find the ratio of the radius of two particles, we will get r dash upon r equals to under root of v dash upon v. Now we have r alpha with that of r proton, that is the ratio of the two particles, as m alpha into charge of proton divided by mass of proton into q alpha, that is charge of alpha. If we put the values here, we will get the correct option here will be option B, that is 10 root 2. As in the above equation, we know the value of mass of alpha and proton particle, the charge on these two particles, and we also know the radius of the proton orbit. We just have to find the radius, and we can calculate the radius of the proton orbit by putting the values of the alpha orbit.